Hi guys, welcome to today's video. This is 2019 paper 1 question 6. We're going to be dealing with numbers in surd form as well as using the median and the mean, as well as a proof on root 2 being irrational. So there's a lot to get through and we're just going to go into the video. Okay, so here's our question. Given that x minus root 32 is equal to root 128 minus 5x, we've got to find the value of x and give our answer in the form a root 2, where a is a natural number. So the first thing we're going to do is move all our x's to one side and put our surds on the other, and that's going to give us this equation. Now there are two options here. First of all, you could just plug into the calculator root 128 plus root 32, and when you do that, the answer you're going to get straight away is 12 root 2, which would be equal to 6x, and that means that x is just going to be equal to 12 root 2 divided by 6, which is just 2 root 2. So that's kind of the quick way to do this, but we could also derive the same thing without the calculator at all. So in order to do it this way, we're just going to have to mess around with the surds a little bit more and rewrite root 128 as two of its factors. And because we want root 2, we're just going to take out root 2 first of all, and that will leave us with root 64. And if we do the same thing for 32, we're going to have plus root 2 again, and the factor remaining is 16, because you're allowed to break up surds into factors like this. But that will simplify to the square root of 64, which is just 8. So that will simplify to 8 root 2 plus 4 root 2, because root 16 is equal to 4. So 8 root 2 plus 4 root 2 is equal to 12 root 2, and that will bring us exactly back to where we got to with the calculator, which is that 6x is equal to 12 root 2, meaning that x is equal to 2 root 2. So that's the answer. Regardless of how you did it, it's going to be worth 10 marks. A gives us this set of numbers, which basically all involve a square root as well as k squared inside that. So we have root 32 k squared here, and then we've got 50, 128, and 98. And what we're asked to do is show that the mean of the set A is equal to the median of set A. So the mean we can simply find by adding all these things together and then dividing by 4. So the mean of set A is equal to all these things added together divided by 4. And I kind of want you to simplify the surds here into something root 2 in each case, but you can kind of cheat using the calculator, because if you just do this addition on the calculator but just leave out k squared, what you're going to get is 6 root 2, and that's going to be multiplied by k because the square root of k squared is just k, and we can add that in afterwards. So that's just going to be equal to 6 root 2k. However, if you wanted to simplify these things down into simpler surds, which is certainly the way I think they want you to do it when they wrote the question, what you would get is that root 32 is equal to 4 root 2k, because it breaks up into root 16 and root 2. The square root of 50 k squared would be equal to 5 root 2k, because root 50 can be written as root 25 times root 2. Root 98 k squared is equal to 7 root 2k, and the square root of 128 k squared is equal to 8 root 2k. And when you put all those things over 4 and add them together, you will of course get that the mean is 6 root 2k. So anyways, that's our mean. Moving on to our median, we are just going to rewrite our set A in these simplified terms down here, because that's going to help us deduce what the median is. And just to make things even more easy, we're just going to write them in increasing order. So starting with this, then we're going to go to root 50, then root 98, then root 128. So now that we have that, to find the median, we're going to look for the term that is the total number of terms plus 1. So in this case 4 plus 1 divided by 2. So we're looking for the 2.5 term. So that's going to be the term that's halfway between the second and third term, and that's what's directly in the middle of the set A. So we're looking for something that's directly halfway between 5 root 2k and 7 root 2k. So it is pretty clear to see that our median is equal to 6 root 2k. So we've now shown what we were asked to show, and that's that the mean and the median of the set are both equal to 6 root 2k. And for doing this correctly, you're going to get 5 marks. So lastly, for part B, we're asked to prove using contradiction that root 2 is not a rational number. So this is one of the proofs that's going to come up in paper 1, and you should definitely be hoping for this because it's quite an easy proof and quite intuitive as well. So the first thing we're going to do is write down our definition of a rational number. A rational number is any number that can be written as p over q, where p and q are both integers. And it's also important to note that it's assumed that p over q is the fraction in its simplest form. So that's the reason we don't write half as 2 over 4, because that can be simplified as 1 over 2. So we keep dividing the top and bottom line down until we can't divide it down anymore. And that's also an important thing to remember about this definition. So with that in mind, we're just going to try and express root 2 as some fraction p over q, where p and q have no common factors besides 1. So if root 2 is equal to p over q, that would mean that 2 is equal to p squared over q squared, because we're just going to square both sides. That would mean that 2q squared is equal to p squared, which means that p squared is even, because it can be written as something by 2, and then by extension p is even, because only an even number squared will give you an even number. So because p is even, we're going to write p as 2k, where k is some integer, which shouldn't be a problem because any number can be written as 2 times something else. And because we've already established that 2q squared is equal to p squared, that would mean that 2q squared is equal to 2k all to be squared, just substituting that in for p, and that's equal to 4k squared. Therefore q squared is equal to 2k squared, because we're just going to divide across by 2. And therefore we can say once again that q squared is even, and also q is even. And that means that q can be written as 2m, where m is just some integer. Therefore, our initial equality that root 2 is equal to p over q can be written as 2k over 2m for some integers k and m, which implies the existence of a common factor 2 among the numbers p and q. However, this contradicts our initial assumption that p over q can be written as a fraction where the numbers involved don't share any common factors other than 1. Therefore, root 2 isn't rational. And that's actually the entirety of our proof. It's very important in maths that when you make an assumption and you proceed based on that assumption, that it's not contradicted later on. And if it is, then whatever you initially assumed actually fails to be true. So that's it for part B. And definitely a proof worth learning because it's one of the few ones that could come up on paper 1. And for getting out part B, you're going to get 10 marks. And that is actually it for this question. I hope you enjoyed the video. If you did, there's going to be other similar videos in the description, as well as some other resources that might help you if you're stuck. And other than that, I'll see you next time.